Hey team, it's Mr. Z, and today we're going to subtract some mixed numbers. We're going to use some of our knowledge from adding mixed numbers, and most importantly, we're going to use common denominators throughout this process. Let's go ahead and do some math. All right, key concepts. Go ahead and take a moment, pause the screen, and make sure that you take the time to read it. All right, the practice, the coup de grace math, what really separates the people who think they're good at math with the people who can. So let's go ahead and look at these mixed problems because they have a whole number, which is just typically the natural numbers without a decimal, and then they have the fractional component. Now, the idea behind this is we're going to process, we know how to subtract numbers. We know how to do 3 minus 1 is 2, right? But the idea is that we have this extra bit and we're going to subtract a little chunk of it. So just to give you an idea to visualize, number 1 is essentially saying I have 3 chocolate bars and I have this much, a little bit over half. Half of 8 is 4, so 5/8 is going to be a little more than half. And I want you to take away a whole bar and exactly half of it. Take these away. You can see visually that I'm left with 2 and some chocolate bars. So it's going to be 2 something. This something is going to be a fraction. So let's go ahead and formally do this. Let's go ahead and try to get exactly how much this answer is going to be. The difference of this is going to be, the first thing I'm going to do is subtract my whole numbers. I'm going to rewrite this and do 3 minus 1 is 2 and 5/8 minus 1/2. Notice how I was able to subtract it immediately. This cleans it up a little bit. Now I can go ahead and go from my my mind that I've trained to scan the denominators. This is like an autopilot right now. You want to build this muscle to do it on site. So let's go ahead and convert it. What is the LCM of 8 and 2? I'm going to start with my lower number, go 2, 4, 6, 8, 10. This is the list of even numbers. Any number in this list of a multiple of 2 is considered even. I hope you all can see clearly that the least common multiple, the least common number in this list is 8. So I actually am not going to change this fraction at all. But I am going to go ahead and multiply 1/2, both the numerator and the denominator, by 4. The reason being is 8. The LCM is the fourth term in the sequence. So 1 times 4 is 4, 2 times 4 is 8, and from here I can go ahead and represent this as 2. 5 minus 4 and the denominator stays the same, and it becomes 2 and 1/8. 2 and something. Notice how the picture is always going to represent the math. In reality, people dealt with pictures first. The math is what was built upon to precisely represent the situation at hand. So most of these problems are going to be rather the same. Let's go ahead and do a couple more. Okay, my difference of this problem was 2 and 1/8. I'm scanning number 2, and immediately on site, you're going to want to go ahead and find the LCM of the denominators, 3 and 4. The reason being is the denominators are always going to be what needs to be the same in order for this to be a true statement. So I always start with my lower number first. 3, 6, 9, 12, 15. And I go ahead and switch off. Usually when I'm writing my lists, I'm going to do a couple for 3, and then I'm going to do a couple for 4. That way I can see that the LCM of both of them are 12. So let's go ahead and get this party started. Notice how I did that even before I started thinking about the problem. So let's go ahead and subtract the mixed numbers. 2 minus 1 is going to be 1 and 2/3 minus 1/4. Now I need to convert these fractions using the sequence. 12 is the fourth term of the multiples of 3. So I'm going to multiply this by 4. Likewise, 4 is the third sequence. I'm going to multiply by 3. Let's process this. This is going to be an equivalent fraction, 8 over 12 minus 3 over 12. And voila, I can go ahead and represent this as 1. And the denominator staying the same. Notice how they merged into one fraction. And then I'm going to go ahead and be left with 1 and 5/12. Okay? Now I'm going to challenge you to do like a number 1. Let's try to visualize the idea. I have 4 chocolate bars, pretending that they're all the same size. And I have nearly a full one. 7/8 is just one away from being a whole. And the idea is that I need to take away 2 and 3/5 of a chocolate bar. So I'm going to take away 1, 2, and most of this. Now you can see what's left is I got this whole and a part and another part. But I don't actually have a very vague answer. So let's go ahead and represent it algebraically. I'm going to go ahead, look at the denominators, 8 and 4, or 5. I'm going to find the LCM. I always start with my lower number. Okay, wrote out a couple numbers in the sequence. I'm going to continue. Nothing matches. Be determined. All will match in time. I continue my list, and the LCM is 40. That took me some time. That's okay. I had faith that eventually they would align. If you have sense in number sense and know your math facts, you might have been able to tell, hey, 8 and 5 both end up being at 40. So let's go ahead and do the problem. The first thing I'm going to take care of is I'm going to subtract my whole numbers. I'm going to do 4 and I'm going to minus 2. And that's going to end up being 2 and 7/8 minus 3/5. And notice how I left a little bit of a blank? I know ahead of time that I'm going to change this problem. I'm going to be multiplying it by something. So I left room ahead of time when I'm writing it in order to save space. So what term is 40 in the sequence of 8? And it's the fifth term. Notice I'm going to go ahead and look at the fifth term and see, hey, where's 40? Well, it's the eighth term. Now, something to help my multiplication is notice these lists of multiples. You should have them on a piece of paper so you can easily reference and produce precise products. Notice, if I don't know what 7 times 5 is, I can look and see that the seventh term of the sequence of 5 is 35. Likewise, looking at my list, the eighth term is 40. And then I have to make sure I include my whole number. And then now I'm going to go ahead and subtract 3 times 8. Well, the third term of my list of eights is 24. My fifth term in the list of 8s is 40. Notice how when we use the LCM, the denominators became the same. And I'm going to subtract 2. And I'm going to go ahead and get 11 over 40. Notice how I skipped that step of writing them together. As you improve your ability to and gain fluency, this will take less time. Okay. So now I do want to go ahead and jump ahead. I want to do a different problem with you because I want to show you a situation that might come up. Let's go ahead and look at number 6. So we're going to skip ahead to 6. I'm going to go ahead and write out my list of multiples immediately. 3 and 5. I see that they're different. This is something that I'm going to have to address. 3, 6, 9, 12, 5, 10, 15, 20. And then I keep going with my lists, and I see a LCM of 15. So let's get this party started. I'm going to do 6 minus 3 first is going to be 3 and 2/3. I'm going to leave a little room to do some multiplication. Minus 4/5. Let's go ahead and multiply. 3 times 5 is 15. 2 times 5. I'm going to go ahead and likewise multiply my second fraction. 15 is the third term, so I'm going to multiply both by 3. So this turns into 3/10 over 15 minus 12 over 15. Okay, this is weird. Can I do 10 minus 12? If I have $10, if I went to the store and tried to buy something for $12, could I buy it? No, they'd send you go home packing. So the idea is like, well, what did I do before in math? What happened when I had to do something like 10 and 12? And let's say it was 310. Could I be able to borrow? Yes. I would have to take something away and then adjust to make sure that I'm following all of the rules for currency and continue my day. So let's go ahead and borrow. I'm going to break up 3 into 2 parts. I'm going to break it up to be 2 and 1, 10/15 minus 12 over 15. Okay, I'm going to be super clever with this. Watch what happens. I hope you all can believe that 3 is equal to the sum of 2 and 1. I'm going to be flexible and change this 1 to be a whole in the denominator of 15. I did all that work. I want everything to have a denominator of 15. And I'm going to represent that whole as 15 over 15. What is 15 divided by 15? Well, any number divided by itself is 1. So now I have 15/15 plus 10/15 minus 12/15. Now, this is going to become 2 and 25/15 minus 12/15. And then finally, this becomes 2 and 13/15. Whew! All right.